Hello and welcome to the NUMT Introduction to Computational Thinking. One of the goals of NUMT is to teach computational thinking in new and innovative ways through our wearable music technology. Before we jump into our curriculum, I want to take some time to explain what computational thinking is and how it can be applied outside of computer science and STEM education. So, what is computational thinking? Essentially, it's a set of 5 strategies that can be used to solve complex problems. These strategies are abstraction, decomposition, pattern recognition, algorithm design, and debugging. While computational thinking is primarily used to solve problems in computer science, these problem solving strategies have applications across all academic subjects and can provide students with a way to generalize how they approach solving problems. Let's explain each aspect of computational thinking in detail. Firstly, there's abstraction. Abstraction means focusing on what's important and ignoring what's unnecessary. In problem solving, abstraction is the strategy of filtering out only the most critical information needed to solve a problem, reducing a complex problem into something that is easier to understand. For example, when a student writes a summary of a chapter of a book they just read, they are choosing what information is the most important. When classifying animals in taxonomy, a scientist might separate them by whether or not they have a spine or gills. A historian might make a period in history easier to understand by drawing a timeline of events. A student trying to solve a math word problem would first read the question and determine what information should be included in the answer. Abstraction is often the first strategy used because it helps problem solvers focus on a particular goal and understand what kind of solution they are looking for. Next up is decomposition. Decomposition means breaking a problem down into smaller parts or multiple steps. In problem solving, decomposition is a strategy that breaks a complex problem down into smaller parts that individually are easier to understand and solve. For example, when solving an algebra equation, a student would not try to solve it all at one step. Doing so would usually lead to errors and leave no way to check their work. To solve an algebra equation, a student would start by breaking the problem down into 3 parts, first using distribution to remove parentheses, then eliminating the constants, and finally dividing the coefficients to solve for x. Decomposition is a powerful problem-solving strategy because breaking a complex problem into smaller, more manageable steps prevents feeling frustrated and overwhelmed by a difficult problem, and it shows how any task can be broken down in a similar way. Next up is pattern recognition, which is the process of identifying patterns or similarities in data. In problem solving, pattern recognition is a strategy that involves looking for similarities and differences in the information presented in the problem. Inductive reasoning is used to make observations and come up with a general rule or pattern that can help solve the problem. For example, in the number puzzle shown, there are several patterns in the sequence that can assist in finding the correct answer. Each object is a grid of congruent squares starting with a 3x3 grid, then a 4x4 grid, and so on. Observing the sequence of grids, you could also infer that each grid has a diagonal filled along with one square in each opposite corner. With this information, you could deduce that the next grid would be a 7x7 with a diagonal of 7 squares and 2 corner squares filled in for a total of 40 white squares, which would be the next number in the pattern. Next up is algorithm design, which is the creation of a set of instructions to solve a problem. It involves the creation of a set of rules, directions, or an overall process for solving a problem. In computer science, the code that programmers write is a set of algorithms whose instructions are carried out by the computer to perform specific tasks or to solve problems. However, algorithms are not just restricted to computer science. Any set of instructions is an algorithm. For example, the recipe for a cake is an algorithm because it is a set of easy-to-follow instructions that turn ingredients into a finished product. Lastly, there's debugging, which means finding and fixing errors in your solution. In computer science, debugging is the act of finding errors in your code that prevent your program from working correctly. But in problem solving, debugging is a strategy to reflect on your problem-solving method, evaluate your solutions, and check your work for errors and fix them. For example, any student who has had to correct grammar or spelling errors in their written work would be using debugging to improve their writing. Now let's bring this all together with an example outside of computer science, the 5-paragraph essay. It's something every student has to learn as it prepares them to make persuasive arguments. Writing an essay uses all 5 parts of computational thinking, whether students and teachers are aware of it or not. Using abstraction, a student would first summarize the information from the reading, using a word count to make sure they are including only the most important information to use in their essay. Next, using decomposition, the student could use a bubble map to outline their key arguments and supporting details. Then, using pattern recognition, the student could use an essay template that shows how every essay uses a similar structure, starting with a leading sentence, then a main argument, transition sentences, and so on. Then, using algorithm design, the student would write a rough draft showing or explaining how their arguments and supporting details will lead to their conclusion. And lastly, using debugging, the student would have their essay checked for grammar and spelling errors, getting feedback from peers before revising their draft into a final essay. Using computational thinking, even a difficult task like writing a long essay can be broken down into more manageable tasks. As we dive into the curriculum in a later video, you'll get to see how computational thinking can be taught using a variety of instructional strategies and embedded technologies, and how NUMT is going to use music as the medium for that instruction. We'll break it all down for you in the next video.